All right, this is Physics 1, Lab 4. The purpose of this lab is to model the oscillating motion of a mass attached to a spring. We compared an experimental and a computational model in order to gain a better understanding of Newton's second law, Hooke's law, and the energy principle. And these are some pictures of our results. So, some fundamental principles. So, Newton's second law, the momentum principle, was used. And if the net force acting on a system is zero, then the change in momentum is zero and the velocity is constant. Hooke's law, the oscillation time period formula, and then the energy principle. Because we needed this because the change in energy of a system is equal to the work done by the surroundings, and you could use this. Experiment setup. The system was the spring, mass, and the earth, and the surroundings were none, so no work was done by the surroundings. And then we put the video into tracker and analyzed its motion. And our initial conditions were that position and velocity beneath the photo. This is a picture of our computational model, the code that we used to simulate this. And then this is more of it continued. So for our results, the change in the energy graph shows the conservation of energy, and the position graphs line up fairly well. They're pretty close, not exactly the same. So in some sources of error, we're inaccurate tracking on the tracker. So when you're constantly clicking the to like follow the motion of the mass, you could have some error there, not clicking in the exact same spot every single time. Human error when acquiring initial values, air resistance, and then just other outside forces that we didn't account for. And then some questions. What does it mean? Yes, the energy principle is satisfied as we can see. That change in total energy stays constant, meaning the sum of the changes in kinetic, gravitational potential, and spring potential energy equals zero. And then what does it mean again? T for the x position, 1.7 seconds, and then T for y, 1.5 seconds. T is similar for both, but the reason for the discrepancy is because mass moves like a spring in the y direction, but like a pendulum in the x direction.